In this problem, we're given a list of n elements, and we can change each element either by leaving it the same or changing its value by 1 up or down. And we want to see whether we can create an arithmetic progression. And if so, we want to see the least number of numbers in the list we have to change such that we can achieve some arithmetic progression. So the key observation to this problem is that an arithmetic progression is always determined by the first two elements. Because if it's a 24 and a 21, we know that every other element in the list has to be offset by 3, because this is minus 3, so this should be minus 3, 18. And same here, 14 and 5, the change is 9. So what we can do is we can just change the first two elements by either we increase it by 1, leave it the same, or make it 1 less. And we can do, for all those 9 possibilities, what we can do is we can just go through the rest of the list and see whether we can change it such that we can achieve this arithmetic progression. So first thing first, we're given n, and then we have an. Now we have read the list in. So since an arithmetic progression is determined by the first two elements, if the list is of length 2 or below, then we know that it'll always be an arithmetic progression. So therefore the answer would always be 0. So if n is less than or equal to 2, we can just see out 0. Otherwise, okay. So let's create something called final count and set that as infinity, and that would be our, this is called final answer. Yeah, and that would be the minimum number of changes we need to get a arithmetic progression. And if at the very end it's still at infinity, then we know there is no such answer. So let's say for int I, and we can either decrease by 1, leave it the same, or increase by 1. And then for int j, in decrease stay the same, or decrease stay the same, increase. Should be like that. Okay. So now that we have this, the new first element of the list is equivalent to a0 plus I, and the new second element in the list is a1 plus j. And then we just keep tab of the previous element, which we'll set as a1 for now. And then let's just count the number of changes we have made. And as of right now, the number of changes would be the absolute value of I plus the absolute value of j. Because if we decrease it by 1, that's 1 change, or if we increase it by 1, that's 1 change. But if you leave it the same, then we aren't making any change. So we just leave it as this. And then we want to calculate the difference for the arithmetic progression, which would just be a1 minus a0. Okay, so now once we've done this, we have to go through the rest of the list and see whether we can achieve an arithmetic progression. So the next element that we'll see would be, that we're meant to see, would be the previous number plus our difference. And now we're going to check if we can achieve this number from the next element in our actual list. So if the absolute value of the next element minus a of k is 1, oh wow, then we have to increase the number of changes. Because if it's 1, it means we can achieve this next element by changing our ak by 1 somehow. Otherwise, if this is greater than 1, that's greater than 1, then we know no arithmetic progression can be achieved, because we need more than 1 changes to make this element into next element. So what we can do in that case is we can just say, okay, in this case it's not possible, so we can just set count to infinity and just break again. Yeah. and then we gotta ensure that we always set the previous element, pre, to be what we calculated as the next element at the start. And then, wait, what did this for loop end? So this is there, and this is this for loop. Okay. And then right here, we have to calculate our final answer, which is going to be the minimum of count and final answer that we already have. Does that look right? Yeah, and then at the very end, after all the loops, we just see out. Oh yeah, we did check if our final answer is equivalent to infinity. Then we know it's not possible, so we output -1. Otherwise, we output our final answer. So yeah, we change this to inf right over here because we want to leave. So if we break here, we'll go all the way here. So yeah, this doesn't really matter, but that is me being safe. Oh, it's small n. And then what is this bug? Oh, expected. If app of next element minus ak is bigger than 1, then we break. Okay, wait, what is this error? Oh, else if lol. Okay, let's run this. This should be 3. Oh, working. So it should be 0 if it's 2 or less. Okay. So you cannot attain here. That's right. And here it's only 1 change. Wait. Okay, good. That looks right. And voila.